Okay, let's go ahead and finish these last three problems. We were just getting ready to factor this perfect square trinomial that we made. So we take the square root of the first term, x. We use that sign, and the square root of 49/16 is 7/4. So the left-hand side now looks like that. So it's really x minus 7/4 times x minus 7/4, but we're just skipping that step and going right to there. So square root, use that sign, square root. Now we need the calculator, or we don't need it. We could do it without, but we like to use the calculator. So this is -1 fraction bar 2 plus 49 fraction bar 16. And that leaves us with 2 9/16, which we don't want, remember. So we do second fraction because we need an improper fraction so we can take the square root of it, 41/16. So that will go right here. And I can tell already this one's going to be similar to the ones that we just did, or the two that we just did. So we have a squared quantity equals a number. So that means it's time to square root both sides and immediately jump down and write plus or minus. So 2 of anything pops out of the radical as 1. So there were 2 of these. Now we have 1. We have our plus or minus. 41's prime. So we're just going to leave it under the radical, but this is 2 4s, which comes out as a single 4. So this is actually the exact same as the last two we've done. Again, not like terms. I can't add a 7 with a radical 41. So I'm going to do the same thing we did on the two previous problems. I'm going to bump it right up there in front of the plus or minus signs. Now, common denominator once again. So now we can write it as one fraction. So it would be 7 plus or minus radical 41. All over 4. See how they have a common denominator 4? So our two solutions are going to be 7 plus radical 41 over 4 and 7 minus radical 41 over 4. And I do require that you write them each out separately like that on the test. And you'll see why as we get closer to the end of the chapter. These are actually going to be the x-intercepts of the parabolas we're drawing. So you need to understand that this is one x-intercept and this is another x-intercept. So that's why we always write them out separately like that. Okay, last two. Wow, long section, and our next one's even longer. Okay, so now we're going to use the square root property on formulas. Same exact steps with the addition of, you do have to remember your things from chapter 5, how to get rid of fractions and things like that. So when I look at this, I go, oh, I need to get rid of that fraction. What's the common denominator? R squared. So I'm going to multiply this side by r squared and this side by r squared, just like we did in chapter 5. So on this side, the whole reason we did that is so that would cancel. So now we have f r squared, I just put it in alphabetical order, equals g uppercase m lowercase m. So f r squared equals g m m. So I know I covered it up, but if you look underneath, that says solve for r. So that means we're trying to get r alone. So do the same thing you'd do if it was a number. If I want to get r alone, I need to do the opposite, which would be divide by f. So then I get r squared equals g uppercase m lowercase m over f. So getting closer. Still don't have r alone. I want to know what r is, not r squared. So we learned on the first page of this section, when you want to undo a squared, you square root it. And I do need my plus or minus still, just like I always do, only Exceptions would be when you're doing like the length of a rectangle or a triangle or something and the value has to be positive. So square root of r squared, those undo each other. Two r's come out as a single r. And nothing's common, so let's split those up into two radicals. G, uppercase m, lowercase m, over f. Okay, so I looked this up to make sure before I did this video, and they want you to rationalize the denominator, just like we did back in chapter 6. So you do have to get rid of the radical in the denominator. Remember how when it's a square root, we need to make 2 of them? So there's 1 right now, so we need to add in another square root f. And remember why we're doing that? Because 2 f's pop out as an f, and we'll no longer have a radical underneath. So now we have r equals plus or minus. This is all under the radical. So should we put it in alphabetical order? F, G, uppercase m, lowercase m. And what do I have in the denominator? 2 f's pop out as a single f. So no radical, yay! And that's why that's called rationalizing the denominator, because we took the radical out of the denominator. So that was kind of a mixture of the beginning of this and chapter 6, which you just finished. So no radicals are allowed to be left in the denominator, so we had to make 2 because 2 f's pop out as a single f with no radical. Okay, now's a good time to shut off the video. Try the last one on your own and then turn it back on and join me and we'll go over it together. Slide this up a little bit. Okay, so we have a equals pi r squared. So they're solving for r. So the minute I see that, I go, oh, I always like the letter I'm solving for on the left. So I'm going to move it over there. So to solve for r means I need to get r alone. So I see this is pi times r. So I'm going to divide both sides by pi. And don't turn it into 3.14. 3.14 is not pi. It's an approximation for pi. And this does not want an approximation. It wants an exact formula. So r squared equals a over pi. And here we are again. We need r, not r squared. So we're going to square root both sides. But if we square root both sides, remember we have to add a plus or minus. I'm going to put a little line here so these don't run into each other. So the square root of r squared is 2 r's come out as a single r. We got our plus or minus there. These don't have anything in common, so let's split them up into square root of a over square root of pi. And once again, we have a radical in the denominator, and we are not allowed to have a radical in the denominator, so that means we have to rationalize. In order for that pi to pop out, I need 2 of them because this is a square root, and I only have 1. So I have to add in 1 more square root pi. Whatever I do to the denominator, I have to do to the numerator. So now we can finish our problem. R equals plus or minus. These are both under the square root, so we can just write a pi or pi a over, in the denominator is just 2 pi's pop out of the radical as a single pi. So there's my answer. Once I get r alone and the radicals are simplified and taken out of the denominator, we're done. Okay, that's it for 7-1. I'll see ya in 7-2. Be safe. Be healthy.